Dear student of class 11, today also I am going to continue with the GP series, part A, exercise 16.3, question number 25. It is given pth term of a GP is x, qth term is y, and the rth term is z of a GP. Show that x to the power q minus r, comma y to the power r minus b, comma z to the power p minus q equals to 1. Now in this case the pth, qth and the rth terms are given. Now next is that you have to consider the first term and the common ratio of a GP. But we cannot consider the first term is a. You may get confused with q, and a is almost similar, and r is already given. So I'll consider x and y is also given. So I'll consider, let alpha is equals to first term and beta is equals to common ratio. Then the Tn term formula that I'm going to use, Tn term is equals to a r to the power n minus 1. Now how to calculate that? Then Tp means n is p. The first term is alpha, the common ratio is beta, and the n term is p. So I'll write a r to the power n minus 1 equals to x. Now then TQ term is equals to alpha into beta into q minus 1 equals to y. Then the TR term will be alpha into beta r to the power y minus z. After getting a value of x, y and z, now then I'll take the left hand side. Left hand side is x to the power q minus r, y to the power r minus p, and z to the power p minus q. Now then I'll substitute the respective values of x, y and z. The value of x according to this equation is alpha into beta p minus 1. So in place of x I'll write alpha into beta p minus 1 whole to the power q minus r. Now then I'll substitute the value of y. Y is equals to alpha into beta q minus 1 whole to the power r minus p. Then I'll substitute the value of z. Z is alpha into beta r to the power minus 1, beta to the power r minus 1 whole to the power p minus q. Now then I'll separate the index over here. The index of alpha is q minus r, and also the index of beta to the power p minus 1 is q minus r. Now then I'll separate alpha q minus r into beta p minus 1 into q minus r into alpha to the power r minus p into beta q minus 1 into r minus p. Then alpha to the power p minus q into beta to the power r minus 1 into p minus q. Now if the bases are same, if the base is same means index we can add. This is according to the law of indices. So q minus r plus r minus p plus p minus q. Then beta to the power p minus 1 q minus r plus q minus 1 into r minus p plus r minus 1 into p minus q. Now the index of alpha, everything will cancel out from here. Q can cancel, p cancel, r cancel. Now it is alpha to the power 0. You know about these things, anything to the power 0 is always equals to 1. Now the index of beta, that I'll multiply over here. If I open this to bracket, then it will be pq minus pr minus q plus r plus this to multiplication qr minus pq minus r plus p. Similarly, these two quantities pr minus qr minus p plus q. Now over here also, this is positive pq cancel, negative pq get cancel. Negative pr, positive pr. Negative q, positive q. Positive r, negative r. so that we can cancel everything over here. Everything is cancelled out. Anything to the power 0 is 1 into beta to the power 0. Beta to the power 0 is also 1. This is equals to right hand side. Now question number 26. P, Q, R are in AP and X, Y, Z are in ZP. Prove that X to the power Q minus R, Y to the power R minus P, Z to the power P minus Q equals to 1. This is almost similar to the previous one. Now P, Q, R are in AP. Then what will be the condition? A, B, C, R are AP means 2B is equals to A plus C. Similarly, P, Q, R are in AP means 2Q is equals to P plus R. AP. X, Y, Z are in ZP means if A, B, C are in ZP means B square is equals to AC. So it is Y square is equals to XZ. Now then, from these two relations, then I'll take left hand side and substitute the values. Now take the value of Y. Then Y is equals to XZ to the power half. Then Y is equals to X to the power half into Z to the power half. Now Y in terms of XZ. Now then I'll take left hand side LHS. Left hand side is X to the power Q minus R, Y to the power R minus P into Z to the power P minus Q. Now first of all, I'll convert this Y in terms of X and Z. Then X to the power Q minus R into, I'll substitute the value of Y. Y is equals to X to the power half into Z to the power half, whole to the power R minus P into Z to the power P minus Q. Then X to the power Q minus R into the index. Now we can multiply 1 into R minus P is R minus P divided by 2 into Z to the power R minus P divided by 2 is equals to Z to the power P minus Q. Now that the bases are same, X and Z. Now in this question, just to run question number 26, P, Q, R are in AP and X, Y, Z are in ZP. Prove that X to the power Q minus R, Y to the power R minus P and Z to the power P minus Q equals to 1. If any three number are in AP means P, Q, R in AP means we can write 2Q is equals to P plus R. And X, Y, Z are in ZP means Y square is equals to XZ. Now that from that relation we can calculate Y to the power XZ to the power half, the value of Y. Then Y to the power Y is equals to X to the power half and Y to the Z to the power half. Now then I'll take left hand side. Left hand side is X to the power Q minus R, Y to the power R minus P and Z to the power P minus Q. Now then I'll replace the value of Y, the relation I'm using. Y is equals to X to the power half and Z to the power half. In place of Y, now I'm going to substitute X to the power half and Z to the power half, whole to the power R minus P into Z to the power P minus Q, so that we can make over here the base same. Now say, after doing these things, these two quantities is same base quantities. Now that the bases are same, then we can add the index. Q minus R plus 2 into Z to the power R minus P by 2 plus P minus Q. Now then X to the power, I'll take 2 LCM, it will be 2Q minus 2R plus R minus P into Z to the power, again I'll take 2 LCM over here, so R minus P plus 2P minus 2Q. Now then over here the simplification, X to the power 2Q minus 2R plus R is minus R minus P divided by 2 into Z to the power R minus P, minus P plus 2P is P plus P, R plus P minus 2q divided by 2. Now after doing these things, I'll use this relation. 2q is equals to p plus r. Now in place of 2q, I'll write p plus r minus p divided by 2. Over here, I'll substitute the value of r plus p or p plus r is same. P plus r or r plus p is same. So in place of r plus p or p plus r, I'll write 2q minus divided by 2 using this relation. X to the power 0 divided by 2, y to the power 0 divided by 2. 0 divided by 2 is 0, y to the power 0. Anything to the power 0 is 1 into 1. 1 into 1 is 1, and this is equals to right hand side. Now next is part B, question number 1. Now try to understand this question. If you save 1 rupee today and 2 rupees next day and 4 rupees and the succeeding days and so on, what will be your total saving in 12 days? If you save 1 rupee today plus 2 rupees next day and plus 4 rupees and so on and so on. First day 1 rupee, next day 2 rupees, third day 4 rupees. If you say in that way, what will be your total saving in 12 days? What will be your total saving in 12 days? This is an application based question. If you say 1 rupee today, 2 rupee next day and a 4 rupee succeeding day and so on, what will be your total saving in 12 days? That means the total saving means total means sum. Sum of n term formula that I'm going to use. Okay. N is 12 days. How much will be your saving? Now A is 1 rupee and A is 1 rupee and common ratio is second term divided by 1. Common ratio is 2, which is greater than 1. Now A is 1, R is 2, N is 12. Then what will be your total saving in 12 days? Sn is equals to formula A r to the power n minus 1 divided by r minus 1. Now A is 1, R is 2 to the power 12 minus 1 over 2 minus 1. 2 to the power 12 minus 1 over 1. This is your total saving. And now the 2 to the power 12, the value of 2 to the power 12. Now 2 to the power 12 is 4096 minus 1. 4095 paise that you will save. And sum of the 12 term is 4095 rupees that you are going to save. If 5x, y, z and 405 are the first 5 terms of ZP, find the value of x, y and z. Now these are the first 5 terms of ZP. So I'll consider the first term. A is equals to 5, first term. This one is the second term. Second term we can consider AR is x. AR square is y, third term. AR cube equals to z. And AR to the power 4 is 405. First, this is second, third, fourth, fifth term. First, second, third, fourth, fifth term. Fifth term is this much. Now using this relation, now easily we can calculate the value of R. Now then After getting a value of r, we can calculate the value of x, y, and z. Substitute the value of a over here. A r to the power 4 is equals to 405. 5 8s are 40, 5 1s are 5. R to the power 4. Now then, which number to the power is equals to 81? Now then, which number to the power 4 is 81? Now it is 3 to the power 4 is 81. 3 into 3 is 9, 9 into 3 is 27, 27 into 3 is 81. And this is, it is r equals to 3. Now after getting r equals to 3, now then I'll calculate the value of x. X equals to ar. The value of a is 5, r is 3, 5 3s are 15. Then y is equals to a is ar is square. Then a is 5, r is square means 3 square is 9. 9 into 5, 45. Now then z, the value of z is ar cubed. 5 into 5 cube. Now 5 cube is 125. 125 into 5. 5 5s are 25. 2 5 2s are 10 to 12. 5 1s are 5 plus 1 6. It is 625, the value of x, y, and z. Now next question is question number 13. Find the ratio of two positive number. Find the ratio of two positive number when the ratio of their arithmetic mean to the geometric mean is found to be 5:3. Find the ratio of the two positive number. First of all, I'll consider the two positive number. Let x and y be the two positive number. Positive number. It is given. Find the ratio of the two positive number means that you have to calculate the value of x is to y. Ratio of the two positive number. And their arithmetic mean is to geometric mean is, and their arithmetic mean is to geometric mean is found to be, arithmetic mean is to geometric mean is found to be 5:3. Find the ratio of the two number. If the two number, we already discussed these things in the previous video. The arithmetic mean of the two number is x plus y divided by 2, and the geometric mean is given by under root xy is equals to 5:3. Now then, it is x plus y divided by 2 over under root xy is equals to 5/3. Now what you have to calculate? Find the ratio of the two number means you have to calculate the x is to y. This is related to the mixture of GP and the ratio and proportion. Read in class 10 these things. X over y over 2 under root xy is equals to 5/3. Now then, squaring both sides, it will be x plus y whole square over 4xy is equals to 25/9. Now then, I'll use the concept of componendo and dividendo. Now I'll use the concept of componendo and dividendo over here. Now dear student, I'll do this question by different method. Now say, this is arithmetic mean, this is geometric mean. Now then I'll write x plus y by 2 equals to 5, ratio comparison, and under root xy is equals to 3. Then x plus y is equals to 10. Then squaring both sides, that you'll get xy is equals to 9. I think this one is the easy method. Now then, I'll calculate the value of y from this. Y is equals to 10 minus x. Now this value I'll substitute over here, the value of y. X into 10 minus x equals to 9. Now that I'll calculate, first I'll calculate the value of x. Now then, open this bracket, it will be 10x minus x square equals to 9. Now these two quantities I'll bring from left hand side to the right hand side. X square minus 10x plus 9 equals to 0. Now result into factor. X square minus 9x minus x plus 9 equals to 0. Then I'll take x common. X minus 9 minus 1 equals to 0. Now it is x minus 9 into x minus 1 equals to 0. Therefore, the value of x is the 9 or 1. The value of x is 9 or 1. When x equals to 9, I'll substitute over here. The value of x is 9. Then 9 into y is equals to 9. Then y is 1. When x equals to 9, then I'll substitute over here. 9y into 9 cancel, it is y equals to 1. When x equals to 1, over here also I'll substitute. 1 into y is equals to 9, then y is equals to 9. Find the ratio of the two number means x is to y. For this quantity, the x is to y would be 9 is to 1. For this, x is to y is equals to 1 is to 9. Ratio of the two numbers. Now this much will do today from GP. Now I think this much of concept of GP is enough for class 11 student ISC batch. Okay, now from next video I'll start complex number. Thank you.